Hi, I'm Peter Adamson, and you're listening to the History of Philosophy podcast, brought to you with the support of King's College London and the Leverhulme Trust. Today's episode, The Final Cut, the Atomic Theory of Leucippus and Democritus. If you stop a historian of philosophy in the street and ask him or her to name one idea from pre-Socratic philosophy that turns out actually to be true, the answer you're most likely to get is atomism. We've looked at some pretty extravagant theories in this series of podcasts. We started with Thales telling us that the principle of everything is water and that magnets have souls, and last week Zeno was trying to persuade us that it's impossible to walk across a tennis court. After all this, it's comforting to come across an idea that looks familiar, that all bodies are made of particles, so tiny they are invisible to the naked eye, and that the interaction of these particles explains the phenomena we see in the visible world around us. The particles are, of course, atoms. And hopefully you've listened to enough of these podcasts to guess where the word atoms comes from. Yes, it's ancient Greek. Tomein means to cut, and atoma means quite literally uncuttables. In other words, atoms are things that cannot be divided into smaller parts. Not because you don't have a sharp enough knife, but because they are by their nature indivisible. But here we've gone no further than the word atoms, and already discovered a big difference between ancient atomism and the atomism of modern science. The atoms of modern science are misnamed. They do have parts which can be divided from one another. Atoms can nowadays be split, with callous disregard to etymology. Furthermore, the parts of these modern atoms, namely protons, neutrons, and electrons, are themselves made up of smaller particles, all those gluons and quarks and whatnot. The particles of the modern scientists, then, are a pretty poor excuse for atoms. Maybe someday the scientists will tell us that there is some smallest or most fundamental particle, or a whole bunch of such particles, which really are indivisible. If they do tell us this, and maybe they already have, because quite frankly I haven't been paying much attention, then these most fundamental particles will be comparable to Greek atoms. Of course, the ancient atomists also arrived at their theory in a very different way than modern science has done. No chemical experiments, no periodic table. Instead, the atomism put forward by the 5th century BC thinkers Leucippus and Democritus was reached by a process of abstract reasoning. Here, a useful starting point is provided by Zeno's paradoxes. As we saw last week, Zeno pointed out problems that result from assuming that distances or bodies can be divided up infinitely. You take a nice familiar object like a tennis court or a giraffe and you start cutting. Divide it in half, divide the half in half, divide the resulting quarter in half, and so on. Zeno exploited the assumption that there seems to be no end to this process. The distance, or the body, turns out to be in some sense infinite, and once infinity is on the scene, paradoxes are not far away. The atomists stop Zeno in his tracks by assuming that if one keeps dividing and dividing, one will eventually hit bedrock. The giraffe, the tennis court, and all other things are made of atoms, uncuttables. Once you've reached the atoms, you're like a film director sending a movie to be shown in theaters. You've made the final cut. This is only one half of the atomist picture of the cosmos. The other half, however, doesn't exist. It's the nothingness in which the atoms move around, in other words, vacuum or void. Here, the atomists were reacting to an argument of Melissus, another follower of Parmenides, who we talked about last week. Just to remind you, he argued that motion is impossible, because for something to move, it must move into an empty place. But empty place is nothing, and there's no such thing as nothing. The atomists reversed the train of thought. Since we can plainly see that motion is possible, there must be such a thing as nothingness into which things are moving. This nothingness is the void. Now, we need to be careful here. It's tempting for us to imagine that the atomists have a conception of three-dimensional space, and that they are saying that this space can be either full, in which case we have an atom, or empty, in which case we have void. But our evidence doesn't show them working with any third notion like space, which is independent of both being and non-being. Instead, they are making a direct reply to Eleatic philosophy. In addition to being, they say, we will have non-being. Being consists of atoms, non-being consists of void, and the atoms move into the void, presumably replacing non-being with being as they do so, exactly what never happens, according to Parmenides and friends. This direct philosophical link to Eleatic thought is well attested in our sources, for instance in Aristotle. So we have good reason to expect a historical connection between the atomists and the Eleatics. As usual, the ancient tradition wants every famous philosopher to be the student of some other ancient philosopher, and duly makes Leucippus an associate of Parmenides or of Zeno. We don't need to believe this, but it's no doubt true that Leucippus was well acquainted with the Eleatic tradition begun by Parmenides. However, he was probably responding mostly to Zeno, and especially Melissus, rather than directly to Parmenides. The later Democritus, then, seems to have taken his atomism directly from Leucippus. Both of them lived in the 5th century BC, but with Democritus, we're really getting to the point where it's misleading to talk about these early philosophers as pre-Socratics. Democritus was in fact an almost exact contemporary of Socrates. One source claims that he was 1 year older than Socrates, which is cutting it pretty close if you want to qualify as a pre-Socratic. We don't know much about the biography of either Leucippus or Democritus, unfortunately. There's even uncertainty about where Leucippus was from. I find it rather suspicious that his home city is reported to be either Miletus or Elea. In other words, one of the two cities most famous for pre-Socratic philosophy. Sounds to me like an educated or maybe not so educated guess. Things are a bit better with Democritus, since we can at least name a home city for him, namely Abdera in Thrace, on the northern coast of the Aegean Sea. As far as their philosophy goes, it's not easy to say where Leucippus stops and Democritus starts. In the ancient sources, many of the atomist doctrines are just ascribed indiscriminately to both of them. Democritus's interest seems to have been wider, though, and for him we have fragments on ethics as well as atomism. Another thing that seems to be special about Democritus, and which I'll come back to, is that he draws strikingly skeptical conclusions from his atomic theory. Here it's tempting to make a connection to Protagoras, the relativist or skeptical sophist, who, like Democritus, hailed from the city of Abdera. We'll be getting to him and his fellow sophists in a few more episodes. But for now, let's get back to those atoms. If I ask you to imagine an atom, I suspect you'll think of a smooth round sphere like a ball bearing. These microscopic ball bearings would bang around, colliding off each other and gathering together to make larger bodies. If that's the image in your head, it isn't far wrong. For the atomists, larger bodies are indeed made of atoms, and atoms do both collide and get collected together. But it turns out that they don't really look like microscopic ball bearings, or rather only some of them do. There are in fact atoms of every possible shape. Some have hooks, some are curved one way and some another so that they can get tangled together and fit snugly into one another if they encounter another atom of the right sort. Different types of larger visible bodies are made from atoms of various shapes and sizes. For instance, Aristotle tells us that for the atomists, the soul consists of particularly smooth, round atoms which can flow around through the body. These are those ball-bearing-like atoms you were just visualizing, and they can collect to form a soul, but not necessarily the rest of the body that houses this soul. There are an infinite number of atoms. This is crucially important for the atomists, and shows again how they are responding to the Eleatics, and especially Melissus. For Melissus, being was one and infinite. For the atomists, being is many and infinite. The difference, as I mentioned already, is that the atomists have integrated void, or non-being, into their world picture. Void separates out being into many things, and these things are infinite. But why do the atoms have to be infinite? Couldn't there be, say, exactly 10 million atoms bouncing around in an infinite emptiness? In answer to this, the ancient atomists could invoke a rule which is sometimes called the principle of sufficient reason. It states that there has to be some good reason or explanation for each feature of the universe. In the present case, atoms must be infinite because there is no reason why there would be any particular finite number of them. Sure, there could be exactly 10 million atoms, but then why not 10,000,001 atoms? The atomists could give the same kind of argument to show why the atoms must have every conceivable shape. Why would they be only spherical, or only come in, say, 10 varieties? Rather, they will have every shape that atoms could have, because there is no reason why any possible shape should be lacking, especially given that there are an infinite number of atoms. Since the atoms are of different sizes, it seems that by the same reasoning there should be atoms of every size, including ones just big enough to see, and still others much bigger than that. There is some uncertainty in the sources here, with some saying that all atoms are invisible to the naked eye, and others suggesting that the atomists thought that there were atoms big enough to be visible, just not in our part of the universe. But I tend to think that Leucippus and Democritus just assumed that atoms must be smaller than we can see. In fact, they could give a good account of this if they wanted to. They explained vision in terms of sheets or films of atoms being shed from the outer layer of visible bodies, which pass through the air and enter our eyes so as to interact with the atoms that make up our soul. Obviously, a single atom can't throw off a sheet of atoms that are part of it, so if there were such a huge atom, there's no way we could see it anyway. Of course, it could still collide with us. I quite like the idea that someday an invisible atom the size of an elephant could come hurtling towards us from outer space. In the unlikely event of such an emergency, do not try to deal with the atom by cutting it in half. Fortunately, the cosmology presented by Leucippus and Democritus makes it clear that enormous atoms are not going to be found around here, if they exist at all. They have a nice explanation of how our cosmos formed out of the atoms. There have always been atoms, and they have always been colliding with one another. The atoms don't just bounce off one another, they also get entangled, partially because of their shapes, like I said, but also because the atoms have a tendency to gather together with other atoms of similar size and shape. This might explain why the soul is able to hold together as a single conglomeration, rather than having all its smooth atoms just go ricocheting off into the void. At the level of the whole cosmos, what happens is that huge groups of atoms start to swirl around in a kind of vortex. The heavier and bigger atoms tend to bunch towards the middle, and the lighter atoms tend to move to the outside. The former make up the earthy and moist bodies of the earthly world, while the latter turn into the fiery heavens. And there's more. In fact, infinitely more. It turns out that there isn't only one cosmos. After all, look around. Does the visible cosmos look like it has an infinite number of atoms in it? No. There must be a vast number of atoms making up the Earth and all the plants, animals, mountains, and so on its surface, and yet another vast number making up the heavens, but vast plus vast still equals a finite number. Besides which, to invoke that principle again, there's no good reason why there should be only one cosmos. Instead, the atomists said, and this is pretty daring, they said there are an infinite number of worlds. Those worlds exhibit every possible combination of atoms. One way of understanding this is that every way that the world could be actually exists out there somewhere. There would be worlds that are very different, maybe worlds made entirely out of cheddar cheese without a cracker in sight, and still other worlds with only small differences, like worlds where giraffes have wings, but everything else is the same. This theory is truly mind-bending, and the atomists don't seem to have explored its implications as fully as we might have hoped. But perhaps we should rein in our imagination just a bit, because there may be a cosmic vortex in all those other worlds too. This would result in many worlds which are a lot like ours, at least in the sense that there is an Earth-like body in the middle, with fiery heavens surrounding it. We seem to have gotten quite far from Parmenides now, even though the theory started out by simply modifying the Eleatic system to allow for non-being and to allow multiple beings instead of a single unchanging one. But notice that each atom in itself is similar to the Eleatic single being. Okay, they move, but they are indivisible, unchanging, and eternal. And there's something else about the atomists, or at least Democritus, that may remind us of Parmenides. You might remember that in his poem, Parmenides distinguished between the way of truth and the way of opinion. His radical metaphysics of one being is the way of truth. It is the hidden reality that we fail to grasp because we are caught up with the appearances of the world. Democritus does something similar, which is at first rather surprising. You might think that he's out to defend common sense against the Eleatics. Giraffes and tennis courts do exist, and he can explain why with his atomic theory, right? But instead, Democritus took a more skeptical line, because he was impressed by the fact that the underlying reality of atoms and void is not evident to our senses. Thus, he criticized the senses, saying in effect that things in the phenomenal world, the giraffes and tennis courts, are unreal, because what is really real is the atomic universe we can't see. He put this in a famous aphorism: by convention sweet, by convention bitter, by convention hot, by convention cold, by convention color, but really atoms and void. In a less famous fragment he says, perhaps echoing Xenophanes and Heraclitus, that no one knows anything, and instead we make do with belief. His position then is that things may appear to us to be sweet and so on, but that is only an appearance. The atomic interactions explain why things seem sweet to us, but the sweetness isn't real. It's the atomic interactions that are real. Here Democritus has hit upon a perennial issue in philosophy. Scientific theories often tell us that the world is very different than it seems at first. This has always been the case, as we've seen with the inventive and surprising theories of the pre-Socratics. The invisible world of quantum particles in modern physics is no less bizarre, probably even more bizarre, than the theories the pre-Socratics came up with. And in both cases, one might ask whether the scientific theories replace the phenomenal world with another world, grasped through more specialized methods, or whether the phenomenal world is retained while also getting explained by the scientific theory. In other words, should we say that giraffes are not real because really all that exists are the atoms that make up the giraffes? Or should we say that giraffes are real precisely because they are made up of atoms? Democritus takes the first option. He thinks that science banishes our familiar everyday reality rather than securing our familiar reality by explaining it. We can see why if we go back to the different approaches used in ancient atomism and in modern physics. Modern physics, despite the mind-boggling world of atomic and subatomic particles it offers us, is still in a way an extension of our everyday experience. The tools of physics, chemistry, and so on are much more powerful than our eyes and ears, but that just means that they enhance our experience of the world. The microscope and telescope are good examples. When you use them, you are still seeing, but you are seeing things much smaller or more distant than the naked eye could see unaided. And even the most outlandish features of the quantum universe are in principle observable, albeit indirectly so. Ancient atomism is not like this at all. The atomists continued in the tradition of Parmenides and his followers by applying pure reason to the task of deducing what the world must be like. Democritus makes this very clear when he contrasts the deliverances of the mind to the deliverances of the senses. Mind tells us about the atomic theory, and thus undermines what the senses tell us, even though sensible reality is supposed to be grounded in events at the atomic level. We can find this deference to the mind elsewhere in Greek philosophy too. You might remember that Xenophanes said that his God thinks. Later on, Aristotle will say that mind is the divine element in us, and that God himself is nothing but a separate mind. But no Greek philosopher pays greater tribute to mind than another thinker who tried to preserve the reality around us from the results of Parmenides' arguments. This was Anaxagoras. In the philosophy of Anaxagoras, mind takes central stage, not only as an instrument for discovering truth, but as the fundamental principle which steers the universe itself. Meanwhile, his account of the bodies in that universe is no less radical and philosophically interesting than the atomic theory. So, join me next week for Anaxagoras on the history of philosophy without any gaps.